Has everybody had a chance to look at number 4 if you hadn't gotten there yet? Okay. We know this Taylor series converges to f of x for all real values of x, then f prime of 1. This is when x equals 1, right, guys? Just looking at it? X equals 1. Okay, that's good to know. So then I can come over here and plug in, well, don't plug in 1 yet. Hold on, wait a minute. I need f prime first, then plug in 1. Well, guys, if this is the general term, what am I going to be doing to every single term? Bringing down the derivative. Bringing down the n and making it to the, x to the n minus 1. I'm just doing power rule to take a derivative of each and every polynomial term, right? A sub n is a constant. Bring down the n minus 1. So therefore, well, okay, I can plug in that x is equal to 1, true? Okay, so I'm going to have 1 to the n minus 1. I'm going to have a sub n times n, but what's my series? Okay, hold on. If I plug in 0, what's my first term? A sub 0, right? It's a constant because it's x to the 0. My next term would be a sub 1, right? X to the n. Sorry, x to the 1. Next one will be a sub 2. Okay, we don't need to go very far. What I'm trying to show you is when you take the derivative, what's going to happen to this guy? He's going to be gone, right? He's going to be 0. This one's going to be a sub 1 plus, bring down the n, a sub 2, x to the n minus 1, right? Okay, here's the dealio. Where do I want my n's to start? So I could say that I need, well, maybe we could even look at it. I need one of these series to match a sub 1 plus 2, a sub 2, x, etc., etc., etc. I need the n to come down. Hey, both of these have the n coming down. Cool beans. I need them to start at 1. Okay, both of them start at 1. What helps us narrow down crossing out e and select d instead? The second term. What's 1 to the n minus 1? It's just 1. Am I raising this guy to the n minus 1? No, I'm keeping the coefficient as I need it to be, but 1 to the n minus 1. There is no n minus 1 needing to remain. Yeah.
Could you have just, instead of writing out that thing,
Oh.
just notice that the 1 to the n minus 1 just goes away, so you just match it.
Yeah, you probably didn't even need to think about I didn't even look at what the bottoms were. I just saw 0 and 1, so I figured that I'd show why. But yeah, you're right. You could have, process of elimination, gotten to D a little bit quicker. Any questions on 4? Okay, we're skipping to 8. Get ahead of me. Go look at 8 if you haven't gotten there yet. How would you start it? How would you think about it? It's always dangerous if you shortcut the learning process and just give a solution when someone hasn't actually thought about the problem yet. We're going to look at 8 and 9. So let me give you a moment. What topic is number 8 asking about? Interval of convergence. Does that make sense? Is it geometric or not geometric?
Yes, geometric.
Which one? If it was not, we do the whole ratio type interval of convergence test. If it is geometric, we just get to set r in between -1 and 1. How do we know? It's all raised to the n power. So the first one would be 2 over x squared plus 1, starting at 1. Second one would be 2 over x squared plus 1 squared. Right? What are we multiplying every time? There's nothing that's outside of to the power of n. Remember the common ratio when we were doing geometric series? So yeah, we can say it's geometric, so how can I shortcut it? What did I just say, or what do you remember about geometric series and convergence? Yeah. 2 over x squared plus 1 has to be in between. Not including, right? Forget the endpoints, who cares? So what can we right away cross off and say, psh, good try? It's not going to be C or E, this is geometric. It can't equal 1 or -1, right? Okay, ideas for solving, because it starts to get kind of messy. Yeah, I was thinking reciprocal, then divide by 2, but divide by 2, then reciprocal. That's good. Do you guys see why we don't want to go multiplying x squareds all over? It's like, I like my x being in the middle. So it might be nicer to go ahead and, if you take the reciprocal, which ironically does not really change much, right? Reciprocal of -1 is -1. Reciprocal of 1 is 1. Multiply everything by -2. Sorry, by 2. So you get -2. Subtract 1. So I get -1. Do you remember what to do now? Oh, because I subtracted 1. Thank you. Well, yeah. But still, it's important to be precise for our own like future problems, right? We don't want to have an error just glaring if we can fix it. You're thinking 0 to 1? Okay. When we square root, we get the plus or minus 1 back, right? How could you double check if you're like, you know what, there's some funny math going on. I'm not so sure I like it, but sure. This one's going below -1 and above 1. This one's going like in between. This one's only going positive. Can't I just plug in numbers and check if worse comes to very worse? Yep. Couldn't I plug in 0 and say, hey, 2 over 1? Does anybody see a dilemma? What did I just plug in? What happened? It was false. So where'd the math go wrong? Plug in 0. My answer right here says 0 is a possible answer. Plug in 0 though. 2 over 1 is 2. 2 is not in between -1 and 1. So process of elimination, we could say, well, that's not going to work. As long as our math is right, which it is, that's a common ratio, right? We could plug in 2. 2 over 5 is going to work just fine. We could try -2, because that's the difference in these two, right? This one says -2 also. -2, 2 over 5, that also works. So D is the final answer, but hold on, where'd the math go wrong? Inverse of, wait, where are we inverting? Well, you guys are thinking down here, yeah, I mean the greater than, but I mean so far our signs are okay. Right here we did the plus or minus square root, but then that would have been fine here. But Gabby went back to the very beginning and she said, wait a minute, with the reciprocal idea. Reciprocals are great when you have equals. What's the dilemma? We don't have. So if worse comes to worse, what could we have done to be safe? Okay, we could have plugged in. That's very true. Couldn't we also have actually done what I was like, ooh, right? Most of us would have done the reciprocal trick. Jason and I both did. Maybe half of you wouldn't, but the majority of calc kids would just do the reciprocal and be like, yay, let's go. But they would end up with the wrong answer if they didn't check and make sure that it worked. If you actually did multiply, you would end up with x squared plus 1 here, 2 there, negative x squared minus 1 over here. What would you do? Because I just multiplied. You'd have to split. And you would have two different statements. You have negative x squared. Technically, it probably should have happened right about here. When you go into both sides, it starts to get really messy. A lot of you are like, that's disgusting. So the better way is that you probably should have split it and said, hey, 2 over x squared plus 1 needs to be greater than negative 1, and 2 over x squared plus 1 needs to be less than 1. You guys have already seen why the answer is what it is. I'm not going to belabor the point any further, but it would have been a smarter idea to split it up, then solve, because with inequalities, sadly, we can't just flip it. Number 9, have you guys gone forward and started looking at that one? Let me give you like 30 seconds in case you haven't pondered number 9. That was the next question. But you just get used to looking at things a certain way, and each of you look at problems differently. Different things jump out at you. So some of you look at this and you're like, oh, it's a geometric series, no big deal. R is equal to? Well, is it geometric? Good. It's almost geometric. It's almost geometric. Come on, some of you thought it was. Why isn't it geometric? It would have been fine if I was only looking at the tops. The factorial on the bottom is always changing. Ah, okay. So it's not geometric. So what do we see? What if we rewrite instead of the ln of 2, say x is equal to ln of 2? When x is equal to ln of 2, what am I plugging into? 1 plus x squared over 2 factorial plus x. Come on, guys. It's e. It's pause, pause, pause. Have some faith. This is e. Who is x? ln of 2. So this one's going to be e to the ln of 2.
So it's 2.
Which is 2. Yeah.
I tried doing that with the ratio test, and I got 2 ln of 2 over n plus 1.
The ratio test doesn't find the sum, it finds the interval of convergence. So it says or gives us the x's, which...
But like if you solved it and you found out that it didn't converge, it would be e.
Yes. The dilemma, though, is that you'd be plugging in with an x already in there. Can you do that with an x already in there? So the whole point is you're trying to find a range of x's. Yeah, I guess if you plugged in, you got a false statement. If it was equal to or greater than 1, then you would say the series diverges.
So if you got ln of 2 over n plus 1.
Limit 0. Because n plus 1, n beats ln. Oh, I said, hey, it doesn't look like ln of 2 has been plugged into something. So I took the ln of 2 out and said, hey, well, he's the guy who was plugged in, x, and then I just put x's in where all the ln of 2's were. I'm like, oh, I know that guy. It's e. From the special Maclaurens. Does that make sense?
Yeah.
Special Maclaurin. Okay. You guys need more time to work to get more questions? All right, ready, set, go.
I finished everything. So
Okay, I'll go peek. I'm going to go peek at 18, 19, and 20. It'll be on the video. If you guys want to just ignore me and listen to it later, that's totally fine. Wow, it's cold. Is that just me? Okay. Just 18 and 20?
you plug in square, but this is multiplying outside. Kind of like when we were doing.
Ooh, that's nasty. So F is the approximate? Ugh.
Like this? Because that's just putting. It's not multiplying it's not going to every term.
No, you saw this was Lagrange, right?
Yeah. What? Yeah.
Because it says max error. Do you saw that? Good job, Alan.
I just don't know how to. I get 19. What's wrong with that? This is Lagrange. Good job, Chuck.
Oh, I didn't see that.
Should I get a lot of X minus 1? Huh? Never mind.
I just stole it.
But I recognize that as an inside. Is it paid for to get your tonsils removed? Huh? How did you oh, first stage. Why not use the way? No, but the ratio.
I have so much works.
You can't have a one. Why can't you have a one there? There will never be one. If you put it as a 0. It's X to the third over top, right? So who's every one? Since you understand. Dad, could you make Z2?
I don't think you need to since it's a calculator problem.
So we just put that.
So I would just consider this function. We have to think about this interval. And think about how this function is going to be a negative even power, right? X squared, but upside down. So it's going to be maximized at the highest value. Right?
Yeah. Actually, it went over my head that you could use a calculator for this.
Oh yeah, there'd be no other way. You could only approximate. Alan, did that make sense? The derivative is an upside down, even powered rational function. Remember normal 1 over x squared, but it's going to be flipped because of the negative. It's going to be maximized at the farthest right it can go. Yeah, which you could graph it, and you could graph in that window, and you'd see the highest is at 1.7.
Oh, there's an N on top.
So then I go ahead and plug in negative 6 all over 4 factorial times 1.7 to the 4th.
Wait. No, but look. I don't think pop doesn't matter that far.
X minus 1 to the 4th. And this one you'd want to graph for the max.
When does P for P series what is conversion? Oh yeah. Oh, because of the power. How is that reduced?
Algebra, which is a college course. 4 times 3 times 2 times 1 is 24, right? 4 factorial. Give me a sec, kid.
Oh wait, this term is.
Ah, stink.
Is this n to the p plus 1 or is it n to the p plus 1?
Stink, it's lower.
Oh wait, I'm stupid. Great citizen. Well, I know 3 diverges. 2 diverges. I can't. I'm just getting last night. I was doing P series wrong. It's P. It diverges. Put the 2 down.
Yeah.
I have a question about
Okay. Do I have the book? There's one. There should be one right there, unless someone borrowed it. Hey guys, who has the CalcBC book? Hey guys, who has the spare CalcBC book? No one has it? Oh, I see. I'm too tall.
Why did I go? I need a book.
Is anybody else looking at this problem with me, guys? Give me 1 second, Dylan. Let's work on this one first. Hey, boys who were asking for number 18, have you been working on your calculators with this with me? Noah, Jason, Allen?
I asked them a question.
Oh, okay. Noah, Jason, Allen, are you tracking with what I'm doing right now and that I'm putting this function into my calculator trying to maximize it? Yeah, from 0.3 to 1.7. The dilemma is if you look at it, you can't see it because it's so slight.
Yeah. The map should be there.
But if you think about the different values, 0.3 minus 1 would be 0.7, 1.7 minus 1 would be 0.7. So either one is going to be maximized. You can just plug in. Does that make sense? 0.3 or 0.7 or 1.7. Okay, those are extra questions. I'm so sorry. I am subbing during period 7 today. I will be available after school.